Today we're putting on our detective hats and diving deep, really deep, into a paleontological mystery. We're going to figure out how science pieced together the life of the largest shark that ever lived, the megalodon, a true phantom predator. Okay, let's get into it.
First things first, let's just try to wrap our heads around the sheer scale we're talking about here. Scientists estimate the megalodon was about 60 feet long. I mean, that's longer than a school bus. It was, without a doubt, the king of the ancient oceans.
And that brings up a huge question, right? If we've never found a complete skeleton, and I mean not even close, how in the world can we possibly know something so specific? How can we know its size, its age, or what its life was like? That's the core mystery we're gonna unravel today.
So to answer that, we first have to understand the fundamental challenge, the main problem with studying any ancient shark. They are, in a very real sense, ghosts of the fossil record.
And here's why. It all comes down to this. Sharks have cartilaginous skeletons. You can feel it yourself. Just wiggle your nose or your ear. That's cartilage. It's soft, it's flexible, and unlike bone, it decomposes way too quickly to fossilize. So for a creature as huge as the megalodon, almost its entire body just vanished. Except for a few absolutely crucial, hardened parts.
So how do you measure a ghost? Well, you follow the clues it left behind. And the most common clue, by far, are its teeth. And that leads us right into our first bit of detective work, figuring out how to size up a giant, all from a single tooth.
Scientists use this really beautiful logical process. It's kind of like a four-step plan. You start with the problem, no skeletons. Then you look at your clue. You've got thousands of fossilized teeth. And here's the genius part. Step 3, you build a model. You look at living sharks today and figure out the exact relationship between how wide their teeth are and how long their bodies are. Once you nail down that pattern, you can take it and apply it to the megalodon's teeth.
Now, this predictable pattern actually has a fancy scientific name. It's called an allometric relationship. All it really means is that there's a reliable proportional link between the size of one body part and the size of the whole animal. This is the mathematical key that lets us unlock the megalodon's true size.
And check this out. This is the kind of data they're working with. You can see it for yourself. For modern sharks, there's this super clear, almost straight-line correlation. As the tooth gets wider, the body gets longer in a very predictable way. So that means if you find a megalodon tooth that's a whopping 5.5 inches wide, you can just follow that pattern and find your answer.
And when you do the math, the result is just astounding. You land on an estimate of about 700 inches, which comes out to right around 60 feet. It's just an incredible piece of scientific deduction, and it all started with one single fossilized tooth.
Okay, so size is one thing, but that's just part of the story, right? Can we figure out how long this massive predator actually lived? Well, it turns out we can. Let's see what else we can dig up.
You see, while most of the skeleton rots away, sometimes other parts besides the teeth do survive. These are the ossified centra, which are basically just hardened vertebrae from the shark's spine. And locked inside these bony discs is a surprisingly detailed record of the shark's entire life.
The comparison here is just perfect. On the left, you've got tree rings. We've all seen those. But look at the right. That's a cross-section of a megalodon's vertebra. The patterns are so similar, and that's because they're formed in almost the exact same way.
Here's how it works. Since sharks are cold-blooded, their growth is tied to the seasons. Just like a tree, they grow a lot faster in the warm summer, creating these wide, light-colored bands. And then they grow slower in the cold winter, which creates those narrow, dark bands. So, if you want to know how old a megalodon was when it died, you just have to count the rings. It's really that simple and elegant.
So now we know its size and its lifespan. Let's pull the camera back and take a look at the world this giant actually lived in. You know, what were the ancient oceans even like when the megalodon was king?
Megalodon's world was a super active, geologically dynamic place. Its hunting grounds weren't some flat, boring seascape. We're talking about massive underwater mountain ranges where new planet Earth was literally being born, huge flat abyssal plains, and the deepest trenches on the planet, all being shaped by the constant grind of tectonic plates.
And this timeline is so important for context. Megalodon was around from about 17 to 2 million years ago. Now look closely at what it doesn't overlap with. It shows up millions of years after the dinosaurs died, and it disappears long before modern humans ever showed up. So yeah, any movie showing a megalodon fighting a T-Rex is pure fantasy.
To be a 60-foot predator in that world, you needed an insane amount of fuel. Scientists have estimated that a megalodon had to eat something like 2,500 pounds of food. We're talking whales, giant fish, other sharks, every single day. That's nearly 1 million pounds of food a year. It was an apex predator on a scale that's really hard to even imagine. So you might be thinking, this is all really cool, but why do we spend so much time and energy trying to solve the puzzle of a shark that's been extinct for millions of years? Well, it's because understanding this ancient giant gives us some critical insights into our world right now.
See, when we study megalodon, we learn about how massive marine predators evolve. We learn about the huge role that top predators play in keeping an entire ecosystem in balance. And maybe most importantly, these lessons from the past give us a vital baseline for understanding and protecting modern sharks, many of which are in serious trouble today.
As the researcher M. Pierce so perfectly put it, this work highlights the importance of preserving the delicate balance of the world's oceans. Every species, both past and present, is like a single thread in this incredibly complex and beautiful tapestry. This whole story is just a perfect example of how science works. The megalodon was a phantom, a ghost, but by following the tiniest of clues, we managed to bring its story back to life. And it really makes you wonder, doesn't it? What other incredible secrets, what other giants from our planet's deep past are still out there, just waiting to be discovered, one clue at a time?